IOE 413, Mathematical Preliminaries Study Guide. This question focuses on the following optimization problem that you see here. Now this problem kind of looks like an LP because it has non-negativity constraints. It has some inequalities. But the objective function is this odd-looking thing that's max over a set. And this function max returns the greater of the values x1 or x2. Note it's not a linear function of either x1 or x2. Therefore, the objective function is not linear. So this is not a linear program. This problem asks you to create an equivalent linear program. That is, a linear program that is equivalent to this optimization problem. So we can do this by introducing a new variable, x sub 3. And x sub 3 is going to be a upper bound on x1 is going to be an upper bound on x2, and we are going to minimize z is equal to x3. So what this does is it's going to force down the maximum of x1 and x2. That was our max function. So it's going to, this part effectively substitutes for the max function that we had above. Now, these are, of course, constraints, so we'll do such that. And we carry along the other constraints we had before. 2x1 plus 3x2 is less than or equal to 5. 4x1 plus x2 is less than or equal to 11. That's 4x1 plus x2 is less than or equal to 11. And x1, x2, and now x3 as well are non-negative. Well, it looks like a nice LP except for one problem, and that is that we have decision variables on the right-hand side of these inequalities up here, and in a canonical LP, we only have constants on the right-hand side, all the decision variables on the left-hand side. So let's rewrite the LP in the final form. So our final LP will be minimize z is equal to just x3 such that x1 minus x3 is less than or equal to 0, x2 minus x3 is less than or equal to 0, and 2x1 plus 3x2 is less than or equal to 5, and 4x1 plus x2 is less than or equal to 11, and x1, x2, and x3 are non-negative. Now, that looks like an LP constraint, linear, that's linear, that's linear, that's linear, that's linear, and that's linear, so we have an LP. This is the answer.